Okay, Assalamualaikum and hello. So today we continue with chapter 8. Okay. So last class we learned about the graphic, which plotting the data you have collected. Now we focus on debugging. So debugging is basically find out what is the error on the code. Okay. I think many of my class already show you the breakpoint, the red dot I put at the side of the code or the script. So that is something related to debugging. Okay. So our objective today will understand the syntax error and runtime error and know how to perform debugging. Okay. So there are several types of error. Okay. So a software bug or error is a problem that exists in the code you have written. The process of fixing the bug is called debugging. Okay. So below this is type of error. Okay, you can either syntax error, runtime error. Okay, so syntax error is basically a typing error. So this one MATLAB can easily recognize. But runtime error, is much more difficult. Okay, so runtime error occurs when the program is running, possibly caused by incompatible array size. So remember, for array operation, the size of array needs to be the same. For metric operation, the array needs to be at a certain size. Okay, so basically when you run it, it will produce error. Okay, and invalid operation. Okay, invalid operation are usually undefined variable. For example, you want r multiplied by 3, okay, but you don't define the r, so it become invalid. Okay, so invalid input output, invalid array index. Okay, logic error or rounding error. Okay, so rounding error is usually rounding number. Okay, 3.5 become 4, right? So something like that. So it will produce a rounding error. So let's start with the syntax error. Okay, syntax error is typing error. Okay, so easily detect by MATLAB, then directly shown in your error in your editor in the form of error bar or error message. This one actually I already showed you before. Okay, the program will not be executed until the syntax error is cleared. Okay, if you run the program consists of syntax error, the error message will be returned to the command without executing the program. Okay, so if you remember, like I said before, if you want to detect an error, you can see here at the side here, there will be red. Okay, and also it will be underlined with a red. Okay, this one. So if the color is not fixed, okay, the color is not fixed, you cannot run the program. That is why it is called syntax error. Okay, and after you resolve it, it will become green. Okay, so this is how you detect the error. So I give you example here. So this is the code from previous chapter, chapter 7. So this one. Okay, so if you look here, there is a red. Okay, so it has red. Okay, means that there is error. So where is the error? You can see here. You just click it. Okay, it is in line 11. So this one is a short coding. But if it is long, it should be shown a lot of here. So if you go here, you can click it and it will show you the error. Okay, and you can see here there is a red line here, underline. Okay, quote character vector is undetermined, so it will show what is the error is all about. So you have to, of course, replace it. Okay, so if the error gone, the red bar is gone and this one will become green. Okay, okay, one more thing, for example, if there is sometimes a warning. Okay, so warning is usually orange. Okay, this one. Okay, terminate the line with semicolon to suppress output. Okay, so orange means just a warning. Okay, you still can run this. Okay, you still can run this, but it is considered as warning. So you can see here, it's not red, it's orange. So basically, you produce an output. So just to suppress it, just put semicolon and the output is not shown, and the coding become green. Okay, syntax error is simple, so easy. Okay, now is runtime error. So when it comes to runtime error, okay, so runtime error is harder to fix since error will be detected by MATLAB only when the program is out, or it will not be detected at all. Okay, so error that can be detected by MATLAB is incompatible, array size, invalid operation. Okay, so error cannot be detected by MATLAB is logical error. Okay, if your logic is not okay, so your output will not be produced properly. So that is considered as logic error. Okay, and rounding error, of course, also the same. So this is the problem, error that cannot be detected by MATLAB. If it can be detected by MATLAB, you can easily repair it. Okay. To debug this type of error, MATLAB has graphical debugger toolbox to work with the breakpoint. So this one already showed you before, breakpoint. Okay. So what is breakpoint? When you try to fix a runtime error, it's often useful if you run the section of the program, then pause and evaluate. So it's just a pause, okay, for the code. So you can see here, for example, I just want to run it until here. Okay, so I run it, it will create a breakpoint here. Okay, so if we run this code, okay, this code is run, but this one is not run. Okay, it's still not run. So this is the current coding operation. So you can either continue is basically continue to the next breakpoint or until the end. Okay, for example, I have two breakpoints, so I press continue, I press run, and it will stop here because of the breakpoint. If I press continue again, it will stop until the next breakpoint. Okay, so that is function of continue, and you want to stop debugging, you can just press this. Okay, so and if you want, after the breakpoint, you want to make it step by step, okay, you just press step. Okay, so you can see each program work. Okay, so let me run this. Okay, so you can see here X, and then X tick is still not running yet, but after you run this, automatically update. Okay, then Y, and then subplot for the second one, X label. Okay, X tick format, Y, and this one. Okay, so that is how you use debugging. So if you have a function, okay, you can use step in and step out. Okay, step in, when you use a function, it will not run the function. So let me show you later. Wait. Okay, so I adjust this. Basically just transfer the magnitude coding into a function here. Okay, so for example, if I run this, okay, you can see here. Okay, if I step it, it will run the function. Okay, you run the function. Okay, sorry about that, I forget to include F here. So if you run this, okay, you step it, okay, it will run the function here, and then just go to the next part. It will not go inside the function. So that is the limitation of debugging using this step. So to if you want to look inside the function, okay, so if I run this again, okay, I step it, okay, and you want to look inside the function, you just press step in. So it will step in into the function. Okay, and then you can just press step. And if you want to step out of this function, you just step out. It will go out from this. okay, it will go to the next part. So that is the step in and step out. Okay, I hope you can understand what is breakpoint. It is much easy to show than the showing the slideshow. Okay, so this one I already explained before. Okay, step in, step out, step, okay, and continuous. This one is for exit debug. Okay, now we move on to the next part, which is undefined variable. So this one, as I mentioned before, undefined variable is basically you don't define the data that you want to use. So you can see here, data you define this, and then data number 2 is this one, but you have data A. Okay, but there is no data A here, only data. So that's why it write undefined function on or variable of data A. Okay, and it will show you at what line the error is produced. Okay, so you can check, for example here line 2, so directly you can determine the error. So I show you there. Okay, you can see here, if I run this, it will unrecognized data, this one. Okay, this is not the error, this one is just a remember this one. Okay, so this is syntax error. Okay, just a warning because you don't put semicolon. Okay, but you can see here, runtime error, you cannot detect it until you run the program. Okay, so you can see here there is no data at line 4, so you just can click it, it will go directly to the error itself. After you repair it, you can run this. So this is another example of array size incompatible. Okay, so basically the size is cannot work. Okay, remember when you want to add, the size of the array needs to be the same. Okay, so this one you have to refer back your chapter 3. Okay, operation. So to repair this, you need to either delete the file or add another number for B. Okay, so this one is just array size. So this one can be detected by the MATLAB. Okay, this one is a trickier for error. Okay, logic error. Program will execute completely, but the answer is wrong. Okay, so you can run the program, okay, completely, but the output is not what you expected. Okay, no error message because MATLAB cannot detect error logic. Okay, logic error. So below are the possible reason for the logic error. Okay, so divide by 0. So if anything that is divided by 0, of course it will become infinity. Okay, so that is a logic error. Okay, array operation mistake, of course the operation is wrong, indexing is wrong. Okay, and looping index mistake, wrong decision. Okay, this one data type mistake. Okay, sometimes your data wrongly choose, you can produce a wrong output, wrong operation or equation. So basically all of this is just logic error. So your program logic is not correct, or you don't properly transfer your flowchart or for pseudocode into a program. So here are example here. So this one is S domain. Okay, this is a transfer function. So you can see here hash is equal to s minus a, s minus 3, and s minus 0.2. So for this case you use the nested loop. Okay, so s is equals to this value and a is equal to this value. This is the transfer function. Okay, and then you print the value. Okay, you can see here the last result should be negative 2.8. Okay, but the return is none. Okay, so basically s minus 0.2 and this one s minus 0.2 also. So in mathematics you can just cut this out. Okay, so you get 0.2 minus 3, you get 2.8. Okay, so if you do it manually, you can get the answer, but if you use the program, basically when s equals to 0.2, a equals to 0.2, it becomes 0, and divide by 0.2 minus 0.2. So 0 divided by 0 is considered as not a number. Okay, this is by the program. Okay, in manual calculation you can get the answer, but in the program you cannot get the answer. It's just write as none. Okay, how to solve this problem? So basically you have to consider the possibility of this. So if s is equal to 2 and s equals to a, so recall back this one, s equals to 0.2, a is equal to 0.2, the same, and s is equal to 0.2, you just write hash is equals to hash minus 3, else you use this. Okay, you just add a condition that special for this condition only. Okay, so that is how you solve one type of logic error. Just add another a decision on the system. So here is another logical error. Okay, this is another logical error. You can see here y equals to x multiplied by 1 plus a. So where x is equal to 3 and a is equal to this one. So you just insert the value here, and y equals to x multiplied by 1 plus a, this one. Okay, so if you run this, you get y equals to 24 and 45. Okay, but if you expand this equation, okay, so x plus xa, this one, okay, and you after you rewrite this, okay, you get a different answer. So this type of error is considered as logical error. Okay, logically it should be the same, but in MATLAB it become different. So you should aware something like this. So basically when you do the coding, okay, make sure you check the output, okay, manually. Okay, sometimes the MATLAB cannot process the output. Okay, now we move on to the last error. Okay, the rounding error. Okay, so the rounding error is an error which results from the finite precision of the computer. Okay, so 8 bytes per variable instead of infinite number. So remember, computer is digital, so the double is actually just 8 bytes. Okay, so 8 bytes per variable. So when you use that variable, okay, so sometimes they can be a rounding error. So this one I think you already learned it in digital. Okay, is limitation of digital computer. Okay, so how to detect it? So you can see here. So you can see here, okay, x is equals to 0.1. Okay, a is equals to 0. So basically as long as a is no less than 0.2, okay, so x is equals to x plus 0.01. So basically x is increasing from 0.10, okay, to 0.11, 0.12, 0.13 until 0.15. Okay, you can see here, if x equals to 0.15, display x is now 0.15. Okay, else, okay, a is equals to 1. Okay, and after complete the loop, if a is equals to 1, of course a is equals to 1, because other condition will go here. Display x equals to 0.15 was not found. So you can see here x is now 0.15 is not displayed. Okay, so basically when you loop this, it should be it should have 0.15, but it's not. Okay, so this is considered as rounding error. Okay, so let's show what happened actually. So you can see here A is 0.11, 0.12 until 0.2. Okay, so X is equal to 0.1. Okay, N is equal to 0. Okay, so display +1 error. This one is just the title here, the heading. Okay, while X is less than or equal to 0.2, X equals to X plus 0.01. So N is equals to N plus 1. This is just to update the iteration. Okay, so and then print the number. Okay, so you can see here, you print for this case the error is X minus A. So the X value is just minus A. Okay, so basically 0.11 minus 0.11 and then 0.24x, 0.124x minus 0.12 for A, something like this. Okay, but when you run this, you can see here the error is 0. But for this one, okay, because of the rounding mistake, you can see here this is a very small number. So E negative 17. So this is why 0.15 cannot be detected. Okay, because of the digital programming problem. Okay, rounding error. So basically, this is just a limitation of the MATLAB. Okay. So I hope you're aware of this, because sometimes when you run the program, sometimes this happen. Okay, there is a error caused by a very small number. Okay, how to fix this? Okay, so okay, before I show you how to fix this, this is also a common problem. So if you see here, B is 1 to 100, okay, and X is 0.1, you multiply by 100, so basically it will become 10. So basically B at the index of 10, so basically the location of 10, and you get the answer. But remember, when you want to do index, it needs to be a integer. Okay, 1 until 1, 2, 3, 4, 5, 6, 7, and so on. So if you do this, basically it will become 10. Okay, 10, but at the end you have a 10.0000. Okay, at the end maybe 2, 3, or 4. Okay, a very small number error. So as a result, your program cannot run. Okay, that is another error of the rounding. Okay, rounding error. So how to solve the problem? Okay, of course you just use round. So round is just rounding the number. So round function can be used to resolve the rounding error. So you can just put round, open bracket, and this one. Basically it will round to the nearest integer. Okay, so it just remove the very small number here. Okay, so this is just an example, a study case, a load factor. So for example, 8.7 until 10 will base on this program. Okay, load factor. Okay, in a power system grid, a load factor can use to evaluate the effectiveness of power plant in generating electricity. So no need to worry about this. So basically, from 0 until 6, it's 5 kilohertz, 5 megawatt, and this one to this one is 10. Okay, this one to this one is 7 megawatt. Okay, 14 to 20 is 6 megawatt, and this one is 6 megawatt. So for this data, of course I don't have the Excel file, but you can create it on your own. So let's just say T start, okay, and then T N load. Okay, so T start, T N load. Maybe I just use P, power. Okay, so you can see here, just put 0, 6, 10, 14, 20. Tn is just equals to square bracket. Okay, this one don't forget semicolon. Okay, 6, 10, 14, 20, 24, semicolon. And the power is, you just write the 58766. Okay, semicolon. Okay, so this is another way to do this. Or if you want to try to run using Excel. Okay, so if you look here, Excel is the location of the data is from B4. Okay, so this is B4 until D8. Okay, so B4 until D8. So, and you have to, maybe I just highlight this. Okay, save it with the name as load factor, and make sure you save at the same location as your code. Okay, and then you just insert the data back. So this one is 0, 6, 10, 14, 20, and then the 6, 10, 14, 20, 24. So this one, okay, and this one, okay, and then lastly 58766. Okay, so save it, and of course you have to close it, and then you just can copy the code. Okay, okay, I have copied the code. So of course this is the error, so you just replace it. So you can see here, replace this. Okay, the error solved, but still red. So you click here, line 9. So what is the problem here? So you can see here, see, it is syntax error, might forget closing the equation. So put here is solved, and now it's green. So if I run this, okay, so unrecognized B4. Okay, what is B4? So you can see here, it is not recognized. So why? Okay, you forget this one. Okay, so you run this again. Okay, you can see here the use of, okay, maybe I should show you the next part. Okay, inner dimension. Okay, so basically it will tell you it is in the line 8, something wrong with the line 8, so it suggests to put dot. Okay, so I run again. Okay, now it produces output. Okay, so this is that I mentioned before, because this is an array, you need to have array operation. Okay, so how about the logical error? Okay, remember that I said it still can run, you can get the output, but is it logic or not? So if not logic, this is called logical error. Okay, when array operation with period symbol is used to replace metric operation below, result in this running program. At this time, no error message is returned by the MATLAB. However, the result is wrong, since the expected output is supposed to be value for each average load. Okay, so you can see here, this is considered as logical error. Okay, after some investigation, multiplication on line 6 should be used. Okay, should be used metric operation to get a single output, thus resolving previous error incompatible. Okay, so you have to investigate what happened. Okay, so basically what happened is that, let me run this for you. So when you run this, okay, when you multiply P, okay, you can see here W will produce work for each time. Okay, but you can see here it is not using sum. Okay, you can use sum here, it will automatically sum. But for this case, this is a problem. Okay, remember average is just summation of this. So to solve this, either you just write sum, okay, sum of W. Okay, you will get the result later. So if I run this, okay, you get the answer. Okay, because when you do the array operation, it will calculate one by one. Or if you don't want to use sum, okay, you can just multiply it back. Okay, but the problem is, remember, for metric operation, okay, you need to have a specific size. So you just flip this, okay, using transpose. You flip the data. Okay, you can see here this one, and dt is also down. So this one you have to flip here like this, and then you can get the answer. So let me run this again. Okay, so directly you get the answer. So that is considered as logical error. Okay, so that's it for this chapter. This chapter is quite short because I already show you how to use the breakpoint, and some of it also I already explained it. Okay, so don't forget to slide in your attendance. Okay, and happy holiday. Okay, that's it from me. Thank you.